Hello students, today we are going to discuss about the topic that is called as cavity wall. So as the name suggests, it is cavity. Okay, so that is some hollow space between two walls. Okay, that is the simple meaning of cavity wall. So in both the figure you can see this cavity, and around this cavity you are having two brick walls. So basically this cavity wall is also called as hollow walls, and it is a wall consist of two parallel walls which are called as the leaves or skin. So here you can say there is one wall here, that is second wall here. So this is inner wall and this is outer wall, and both the walls, that both the parallel walls that are called as leaves or skin, that are separated by continuous air cavity, and it is interconnected by the ties at regular interval. Because as such there is no connection between these two walls, at certain point you have to provide certain connections. So for that connection at certain interval, that is at certain regular interval, that interconnection is provided by means of ties. So it's this kind of tie, that is wall ties, they will connect both the walls, inner and outer wall. So generally this outer wall, which is the external wall, it is called as outer leaf, एंड द इनर वॉल विच इज कॉल्ड एज इनर लीफ. जो अंदर की तरफ होगा वो इनर लीफ, जो बाहर की तरफ होगा वो आउटर लीफ. ओके, एंड बोथ द लीव्स ऑफ द केविटी वॉल may be having equal thickness or unequal thickness depending upon the requirement. If equal thickness is provided, then it is generally useful for the non-load bearing wall. But if internal leaf, it may be made thicker than the outer leaf. जो अंदर का वॉल है वो अगर आउटर से अगर ज़्यादा थिक रखते हैं, so it will meet the structural requirement, so that can be utilized for the load bearing wall also. Okay, and the two walls are tied together, both the walls that are tied together with the help of metallic or terracotta ties to obtain the structural stability. So just to have the interconnection, such kind of wall ties that will connect both the inner and outer wall to bring the structural stability to your particular cavity wall. Now, what are the reasons for providing this cavity wall? So first thing is prevention of dampness. जो भी moisture आता है उसको prevent करने के लिए normally cavity wall provide की जाती है, because moisture cannot enter from outer leaf to inner leaf, as there is no direct connection between both the walls except at the point of wall ties. Okay, hence it will decrease the penetration of dampness from outside to inside. So first is prevention of dampness. Second is heat insulation. As this air is there in cavity, it will act as a non-conductor of heat, and it will try to maintain the uniform temperature inside your building. So the cavity wall has around 25% greater insulation than the solid wall. So from the um, एक्सपीरियंस एंड स्टडीज इट शोज दैट केविटी वॉल के अंदर 25% ज़्यादा इंसुलेशन होता है एज कम्पेयर टू सॉलिड वॉल एज फार एज द टेम्परेचर इज कंसर्न. नेक्स्ट इज साउंड इंसुलेशन. सो एक्सटर्नल नॉइज, इट इज़ नॉट अलाउड टू कम इनसाइड ड्यू टू केविटी, बिकॉज बीच में आपका कैविटी है, सो इट विल नॉट अलाउ द बाहर का नॉइज टू कम इनसाइड योर हाउस. सो दैट इज कॉल्ड एज द साउंड इंसुलेशन. नेक्स्ट इज लेस लोड ऑन फाउंडेशन, because it is having thickness which is less than solid wall. That's why the load on the foundation is considerably reduced. So you can say ultimately there is a less load is coming on the foundation. Also, it is helpful in preventing efflorescence. So basically, these efflorescences are nothing but the powdery deposits of salts that are sometimes visible on the brick wall. So this, if you are going for this cavity wall, there are less chances, or that efflorescences, they are greatly reduced because this connection between the two walls. Also, it is economical. Okay, because less material is used. That's why the construction cost is also reduced to around 20% than the solid wall. Now, as far as the construction procedure is concerned, just to try to see in this particular figure, so it is constructed with the two leaves, inner and outer leaf with the hollow space. So here in this figure, you can see there are two leaves, two walls that are provided. Okay, and this is ground level. Okay, so this is outer wall and this is inner wall, and on the floor level, the damp proof course is provided just to avoid the entry of dampness inside your particular house. So, and here you can see there is a air brick. okay, just to provide the proper ventilation. And this cavity that is provided in between both the walls, and both the walls that are connected with the metal ties at certain regular interval. Okay, so the width of the cavity is constant. So this generally width of the cavity, ये कितना width होना चाहिए, so that remains constant, and that range between 50 to 100 mm. So generally the outer wall, so जो यहाँ पे outer wall दिखाया है, this outer wall that is generally half brick thick, while inner wall, so this inner wall, this inside house, that is it may be half or one brick thick wall. And this cavity is continuous in vertical direction except at the lintel on opening. So generally it may be continuously आप इसको provide कर सकते हैं vertical direction में, except at the opening like in lintel. So the inner and outer wall, they are interconnected by means of metal ties and bonding bricks. So normally these metal ties that are used to have the interconnection between the two walls. And the outer wall is generally constructed in stretcher bond, Flemish bond, or English garden wall bond. And the bottom of the cavity, so here you can see there is a provision of air brick. So here in this figure you can see this air brick, okay, that is provided with certain hollow spaces. So certain kind of air bricks that can be provided at the bottom of the cavity. And this bottom of the cavity wall, it should be well ventilated by the use of air bricks and ducts. So to provide the proper ventilation, such kind of air bricks may be provided at the bottom of the cavity wall. Now, we should know about this metal ties or the wall ties. As we have discussed, these metal ties that are the connecting member between the outer and inner wall. Okay, so basically these metal ties are generally wrought iron or mild steel bars. So mild steel के या wrought iron के bars ही होते हैं that are coated with tar and galvanized to be rust resistance. सो रस्टिंग फ्री होने चाहिए, काट नहीं लागी जो જોઈએ બરાબર. So that's why they are coated with tar or they are galvanized. So there are varieties of such wall ties that are available. Okay, so basically where high corrosion potential is there, then copper or bronze metal ties are also used. And generally they are the bars of 3 to 4 diameter, and their ends are generally twisted. So you can say there is a twisted ends, and generally they are turned down, so that whatever this way they are turned down at the center. So whatever water that is coming up, that moisture will travel along them and it will drop down into the cavity. So this type of twisting and turning is generally provided in the metal tiles. So here these are some of the butterfly wall tile. This is vertical twist wall tile. This is double triangle wall tile. So there are varieties of wall tiles that are available, and varieties of twist and turns, and they are used to interconnect both the walls. These metal ties are placed at horizontal distance of 900 mm and vertical distance of 450 mm. So here you can just see this. This is one metal tie in the particular section. So when you just see in the elevation, so this is the vertical distance. Vertical distance between the two metal ties. It is generally 450 mm, and horizontal distance between the two metal ties, it may be around 900 mm. That is generally kept, and generally they should be arranged in a staggered way. It should not be continuous, it should be in a staggered way they are arranged. So these metal ties are very important part of cavity wall that provides the interconnection between outer and inner leaf. Now this cavity wall, they can be provided for flat roof as well as inclined roof. Okay, so generally the cavity should start near the ground level, and it should end near the eaves level for the sloping roof. So when we are talking about sloping roof, so this sloping roof, this lower end of the inclined roof, that is generally called as eaves. So this cavity, it would start near the ground level. So this is ground level. So here we are talking about pitched roof. So this cavity may start above or near the ground level, and that will end. So here this is the end of your particular cavity. So it should be a continuous cavity, and opening, it is the opening is there, okay, here. So it will be continuing up to the eaves of the sloping roof. or in case of flat roof, if instead of sloping roof we are having a flat roof, so this is the coping, this is cement concrete coping of your flat roof. So this way, the same starting point just above the ground level, this cavity will start. So here you can see this is cavity, and this will end up to the coping of your flat roof. So you can say in the pitched roof it will start just above the ground level, reached up to the end of the this eaves level, and here in the flat roof it will end up to the coping level of your flat roof with the parapet wall. And this cavity which should start 15 centimeter below DPC, okay, and so that the condensed moisture below the level of DPC can be drained out. So generally here you can see this DPC, okay, so it should start 15 centimeter below this downproof course. So here you can see below dampproof course this cavity will start. So whatever moisture, condensed moisture, it would be there, that will be drained out easily. And the bottom of the cavity should be at least 15 centimeter above the outside ground level. So here also you can see some difference. So 15 centimeter above this ground level and 15 centimeter below DPC. That are the some general requirement of providing or starting point of the DPC. ग्राउंड लेवल से 15 सेंटीमीटर ऊपर और DPC से 15 सेंटीमीटर नीचे, वहाँ से आपका नॉर्मली कैविटी में भी स्टार्टिंग. एंड इन द फ्लैट रूफ इट विल रीच अप टू द coping, and in flat roof it will reach up to the end of eaves level. Okay, so this is regarding cavity wall, cavity wall for flat roof and cavity wall for the pitched roof. So here in this figure you can see the 3D sketch, that is isometric view. So here this cavity, continuous formation of cavity, it is quoin, that is your corner bricks, then perpendicular joints and horizontal or bed joints, and here there is a provision of wall ties. So at certain regular interval we have to provide this wall ties, that is the interconnection between two walls. And here you can say this is your DPC, damp proof course. And here sometimes whatever the air cavity which is developed, you can fill certain insulating material also, okay, in the whatever cavity between the two walls. So there are these are all the cavity walls with the metal ties. So these are all the varieties of metal ties already we have discussed that are available, and its horizontal distance should not be greater than 900 mm, and this vertical distance should not be more than 450 mm. So there are varieties of ties which are generally used to interconnect both the inner and outer leaf. So here this cavity wall insulation is given. So this is the wall, okay, which is having no insulated space. It is fully filled with the air cavity. But if you are using certain insulating material just to have the effective insulation, sound insulation, heat insulation, then the certain insulation material can be filled inside. Okay, so this certain fill, that insulation material that are widely used, that is mineral wool or polystyrene beads, and sometimes this polyethylene foam is also used. So this kind of insulating material can also be filled in the cavity which is between two wall, inner and outer wall. So that will improve the insulation. So here also such kind of insulation, cavity wall insulation is shown in the figure between inner and outer leaf. Now we will discuss about this construction of cavity at certain typical positions. So this is the related to construction of cavity at foundation. अगर आपको फाउंडेशन लेवल से कैसे स्टार्ट करना है. So cavity may extend up to concrete base or 15 to 30 centimeter below DPC. So here you can see in this first figure, this is your foundation concrete. So as per requirement, you can start your cavity from the base of the particular concrete base, or sometimes you can, as we have discussed earlier also, this particular cavity, it may start that is 15 to 30 centimeter above this concrete base. So here is 15 to 30 centimeter below concrete base, or 15 to 30 centimeter below your DPC. So DPC से 15 से 30 सेंटीमीटर नीचे, या फिर योर कंक्रीट बेस के ऊपर आपके वापस कंक्रीट फिल प्रोवाइड करके भी आपका DPC यू कैन स्टार्ट. ओके, सो इन केस वेयर द ग्राउंड लेवल इज हाई, जैसे बात किया है यहाँ पे, The cavity wall may start from top of the foundation concrete extending up to 15 centimeter below the DPC course of plinth level. So here this is the case. DPC is a 150 नीचे. Okay. So in that case, you can start from the top of the foundation, that is 15 to 30 centimeter ऊपर से भी start कर सकते हैं. And bottom of the cavity should be at least 15 centimeter above your outside ground level. So bottom of the cavity, so this distance बॉटम ऑफ द कैविटी जो भी है ग्राउंड लेवल से 15 सेंटीमीटर ऊपर होना चाहिए टू अवॉइड द एंट्री ऑफ मॉइस्चर. एंड सेपरेट डीपीसी should be provided for both the leaves. So as you are having two separate walls, so here you can see this DPC damp proof course that should be provided separately for both the leaves. Okay. So here the provision of air bricks and duct is provided to bring the ventilation to your cavity wall. So in short, you can say that in general you can start this cavity from the base of the concrete or either 15 to 30 centimeter above the base of concrete and 15 centimeter above ground level and 15 centimeter below your DPC, and separate DPC may be provided to both the walls, and as per requirement you can alter this. Next is construction at opening. So generally opening, this cavity is discontinued at a lintel level and seal level of the windows, doors and ventilators. As the opening can provide the easy access to the dampness, क्योंकि पानी आराम से आ सकता है, तो यहाँ पे आपको डिसकंटिन्यू करना है. ठीक है. So generally at the openings this cavity may be discontinued, and the top of the openings of doors, windows, stone or brick arch or the lintel is generally provided. तो जहाँ पे भी आपका ओपनिंग है डोर्स और विंडोज का, stone or brick arch that can be provided. Otherwise you can provide the lintel to carry the loads from the structure. So generally you can see this is the details at the lintel. So above this opening this kind of lintels are provided, and that is provided all over with the damp proof course. Okay. And for this seal level the DPC is generally provided below the seal block or above the lintel top. So as I have told you, this lintel top के ऊपर आपका DPC है, या फिर below seal level you can provide your damp proof course just to avoid the entry in the cavity. Okay. So generally this seal level that can be provided in the form of slab, RCC slab, or it may be provided a very strong stone as a seal. So generally this DPC is provided below the seal block के नीचे or above the lintel top, just to prevent the entry of moisture or water inside the cavity. So this kind of pressure arrangement are done whenever this cavity is extending at the opening. Next is construction at parapet and eaves level. So already we have discussed. In flat roof, the cavity is provided up to the top of the parapet wall of the terrace and up to the bottom of the coping. So here you can see this is the coping. Okay, so in the flat roof it will extend up to this, and all over you can provide this DPC, and the DPC should be laid below coping block of parapet. So this complete DPC is to be provided covering the full width of wall. And in case of flat roof, the cavity is stopped at mid height. अगर आपने यहाँ पे mid height पे कर दिया, it is not extended up to your deep this coping तक नहीं गया. In first case you are going up to coping, but in second case if you are just stopping your cavity in between. Okay. So in that case this DPC is laid to the full width of the wall where the cavity joins the solid wall. So here this cavity wall ends. So here at this position you have to provide DPC as at the point where it joins solid wall. Okay. So this kind of proper DPC damp proof course is to be provided just to avoid the entry of moisture in your cavity. And in case of sloped or pitched roof, it is extended up to the near the eaves level. So here this is the eaves. So this cavity may be extended up to eaves level in case of pitched roof, that already we have discussed earlier also. Now there are as there is a cavity between the two walls, there are chances of the dropping of mortar or bat are always there. जब भी काम चल रहा होता है हमारी वॉल का, तो ब्रिक बैट या तो फिर कुछ आपका मटेरियल दैट में drop or that will come inside your cavity. So dropping of this mortar is generally prevented by covering the cavity by wooden batten. So this kind of wooden batten can be provided. So this type of wooden batten that can be provided above your cavity, that is consisting of the teak wood with its thickness marginally less than the width of cavity. जितना भी width of cavities है उससे छोटा एक बैटन का पार्ट आप cavity पे रख सकते हैं, just to avoid the dropping of whatever brick bat or any material mortar inside your particular cavity. Now as far as simple design is concerned, the outside portion of the cavity wall should be treated only as a protective skin and not as a member of load bearing wall. So this is the general design consideration कि जो आपका बाहर का wall है, generally it is to be considered as a non load bearing wall, and the inside portion it should have sufficient thickness to carry the load safely. So these are the two basic design considerations that are that are to be followed when you are designing for the cavity wall construction. Now these are the precautions to be taken while constructing a cavity wall. So first point, as far as possible, interior and exterior leaf should be disconnected from each other. So that is the first requirement because cavity provide करना है, ठीक है. Outer leaf or inner leaf of the cavity wall having thickness of half brick, it should be connected with the stretcher bond. So if it is a half brick, then it can be connected with the stretcher bond. And each leaf they should have their separate DPC. दोनों leaf का separate DPC होना चाहिए. And the horizontal DPC should be provided at least 15 centimeter above the bottom of cavity. So horizontal DPC 15 सेंटीमीटर ऊपर आपको प्रोवाइड करना है DPC, ओके, from the bottom of the cavity, and the bottom of the cavity should be at least 15 centimeter above your ground level से 15 सेंटीमीटर ऊपर and DPC से 15 सेंटीमीटर नीचे आपको प्रोवाइड करना है cavity. The ties should be rust free proof material and should be protected by galvanizing or tar coating. So કાટ ના લાગી જાય એના માટે તમારે રસ્ટ પ્રૂફ મટીરિયલ યુઝ કરવાનું છે, it can be galvanized and it can be coated with tar, and cavity should be extended from top of the roof to the foundation. So that is as per requirement. And top of two leaves should be built with the solid block to take up the structural load. जो भी आपका top of the two leaves है, generally that is constructed with solid wall so that it can take the structural load. Also, opening should be specially treated, and doors and windows reveals जो exposed portion होता है doors and windows का, it should be provided with the vertical DPC because जो exposed portion है वहाँ पे moisture ना आ जाए, इसकी वजह से आपको वहाँ पे vertical DPC भी provide करना चाहिए. And window sill that can be provided with the precast concrete slab or brick headers. So more precautions are to be taken when this cavity is coming at the opening, and great care should be taken to check the entry of vermin or mosquito inside the cavity. So कुछ worm biological agent या mosquito they should not attack your inside airspace. Mortar dropping or brick rubbish should not fall inside the cavity. So already we have discussed the wooden batten can be provided, and cavity should be properly drained and ventilated by providing the weep holes just below the DPC in doors and windows, and the weep hole should be provided above the DPC. So here you can see this kind of holes here, these are called as the weep holes. Okay, so that can be provided to allow the air into cavity and by allowing the water to drain. So thus this kind of holes that are called as the weep holes that can serve both the purpose, that will be utilized as a ventilation purpose also, and at the same time if certain moisture is coming through the cavity that can be taken out, and that is called as weep holes. So in this isometric view you can see at certain interval you are having such kind of weep holes that can be provided, okay, for the ventilation and draining purpose. So to summarize all the whatever cavity wall construction we have discussed, the following advantages can be obtained by constructing a cavity wall. First is moisture prevention, as there is no direct connection between both the walls. Heat insulation, it can be improved around 25%. Also good insulation against sound, outer noise will not reach to inner house. Also cheap and economical, because this cavity wall are nearly 20% cheaper than the solid wall. Then less load on the foundation पे कम load आएगा, effluence reduction, and for the same thickness of the material, cavity walls are stronger than solid wall. Okay, so you can say there are varieties of uh, advantage that can be obtained with the help of cavity wall, and by taking some precautions you can build a good cavity wall, and you can economize your construction as well as the insulation. Good insulation can be brought to your structure. So with this I would like to end my presentation. Thank you very much.